Welcome to Lights Out Stories. New stories drop every week. If you want to be here when they do, hit subscribe and settle in. Tonight's story is called The Deep Line. It's about the men who decided to connect two continents by unspooling thousands of miles of copper wire and gutta percha into the black, crushing silence of the North Atlantic in ships that were barely equal to the task, using technology that had never been tested at that scale. Guided by an idea so ambitious that most serious people thought it was impossible. This is the story of how they did it anyway. So get comfortable, turn the lights down, and let's get into it. In the summer of 1866, a ship sat in the harbour at Sheerness, England, and she was the largest thing afloat. Not the largest warship, not the largest merchant vessel, the largest thing afloat, by almost any measure you chose. She was 692 feet from bow to stern. She displaced nearly 19,000 tons fully loaded. She had been designed by the greatest engineer of the age and had been built over 3 years at a cost that had bankrupted the company that built her and very nearly taken down the man who designed her. Her name was the SS Great Eastern. She had 5 funnels and 6 masts and paddle wheels on both sides and a screw propeller at her stern, and she could carry 4,000 passengers in conditions that the steamship lines of the day could not match. She was, in almost every sense, a triumph of engineering. She was also, as a commercial passenger vessel, a catastrophic failure. She was too big for the ports that existed, too expensive to operate, too far ahead of her time in every way that mattered for turning a profit. She had changed hands multiple times, each new owner discovering in sequence what the previous one had already learned. The ship was magnificent, and the ship was ruinous, and there did not appear to be a use in the world for which her particular combination of size and capability was suited, until someone decided to lay a cable across the Atlantic Ocean and realized that the Great Eastern was the only ship on Earth large enough to carry it. Thomas Alderton had been an electrician for 11 years, not in the modern sense of the word, in the Victorian sense, which meant something different and more specific. He was a man who understood the behavior of electrical current through copper wire, who understood resistance and signal strength, and the way that the quality of insulation determined whether a message sent at one end of 1,000 miles of cable arrived intact at the other, or arrived distorted beyond reading, or did not arrive at all. He had learned this work at a telegraph company in London, had spent 4 years in a basement room testing wire, measuring signal decay, developing the patience that precision work requires. The work was not glamorous. It was quiet and methodical, and it rewarded the kind of attention that most people found difficult to sustain. He had the kind of attention it rewarded. He was 31 when they offered him a position as an electrician aboard the Great Eastern for the 1865 cable expedition. The salary was good. The work was exactly what he had been training for without knowing it. He accepted without asking many questions, which was perhaps naive, because if he had asked the right questions, someone might have told him what the previous attempts had already demonstrated, which was that this was harder than it looked. Much harder. The idea of a transatlantic telegraph cable had been proposed in the early 1850s. The logic was simple. The electric telegraph had transformed communication on land. What had once taken days or weeks by courier now took minutes. The financial houses of London and the counting rooms of New York and the government offices of every major power had restructured their operations around the expectation of fast communication. But the ocean interrupted everything. Between Britain and America lay 2,000 miles of water and 2 weeks of sailing time. News that was urgent when it left one shore was history by the time it reached the other. Markets moved on information that had crossed the Atlantic by steamship, which meant they were always operating on a delay that no amount of cleverness could eliminate. A cable would change this. A cable, in theory, would make the two continents into a single communication network. A message sent from London at noon could arrive in New York at noon. The implications for commerce and diplomacy and the flow of information were difficult to fully calculate, which was part of what made the idea attractive to certain kinds of minds. The problem was the cable itself. To span the Atlantic, you needed roughly 2,000 miles of it. Each mile of cable was a composite structure, a core of copper strands for conducting the electrical signal, wrapped in layers of gutta percha, a natural latex derived from Malayan trees, for insulation, wrapped in hemp and iron wire, for strength and protection. Each mile weighed approximately 1 ton. 2,000 miles of cable weighed approximately 2,000 tons. No ship afloat in the early 1850s could carry 2,000 tons of cable. This was the first problem. The second problem was the ocean itself. Thomas joined the expedition at Sheerness in June of 1865. He had expected the ship to be impressive, and it exceeded expectation. You could not stand on the dock and look at the Great Eastern without understanding, in a way that went past intellectual comprehension into something more physical, that you were looking at something unprecedented. The sheer scale of her was not a fact you processed so much as a fact you inhabited. Her black iron hull ran the length of several city blocks. Her paddle wheels were 56 feet across. Scaffolding and ropes and the constant activity of provisioning and loading gave her the look of a small city being assembled rather than a ship being prepared. He stood on the dock for a long time before boarding. He was trying to take her in all at once and could not do it. You could not see the whole ship from any single point on the dock. You had to move along it, section by section, letting the scale accumulate in your understanding rather than arrive all at once. He eventually gave up trying and walked up the gangway. He was shown to his quarters, a cabin shared with 2 other electricians, comfortable by the standards of a working passage, and then taken to the cable tanks. There were 3 of them, circular tanks built into the hull of the ship, each large enough to contain a house. The cable was coiled inside them in concentric loops, layer upon layer. The full weight of 2,000 miles of wire and insulation and iron armor resting in those 3 spaces. The smell of the tanks was particular. The organic warmth of the gutta percha, which was a living material in the sense that it responded to temperature, softening in heat and stiffening in cold, requiring constant attention to its condition. Thomas spent 2 days examining the cable before they sailed, running test signals through it from end to end, measuring resistance values, checking the integrity of the insulation at regular intervals. The cable was in good condition. He noted this in his log, the first entry in what would become a detailed record of everything that happened on the voyage. He had been told to record everything. He was beginning to understand why. The cable was remarkable to look at up close. A cross-section would have shown 7 strands of copper wire at the center, twisted together and coated in 4 layers of gutta percha, applied in alternating directions. Around that insulating core, a layer of hemp saturated in compound. Around the hemp, 10 iron wires helically wound, each iron wire itself wrapped in fine manila fiber. The finished cable was roughly an inch in diameter and felt, when you held it, solid and purposeful, heavier than it appeared. The iron exterior rough under your fingers, and the whole thing slightly warm from the tanks. It did not look like it could carry a human voice. It could not carry a human voice. What it could carry was Morse code, dots and dashes, the presence or absence of electrical current, translated by trained operators into letters and letters into words. Not fast. The resistance of 2,000 miles of copper wire spread the signal, smearing a sharp dot into a longer wave, requiring that messages be sent slowly and read by sensitive instruments rather than by ear, but fast enough. A message that would take 2 weeks by ship could cross the cable in minutes. Thomas understood this. He had spent years working with exactly this kind of signal. What he had not fully appreciated, standing in the tank room of the Great Eastern on a June afternoon, was the physical courage the thing represented. 2,000 miles of it, going into the ocean. And if it broke, you might never get it back. They sailed on the 23rd of July, 1865. The plan was to sail west from Sheerness to the Irish coast, pick up the shore end of the cable already laid at Valentia Island on the southwest of Ireland, connect it to the cable aboard the ship, and then proceed west across the Atlantic, paying out cable as they went until they reached Heart's Content Bay on the coast of Newfoundland. 2,000 miles of ocean at a paying out rate of roughly 6 miles of cable per hour. The crossing would take about 2 weeks, assuming nothing went wrong. Thomas stood at the stern of the Great Eastern on the morning they left Valentia and watched the cable enter the water. The paying out machinery was a mechanical system of drums and brakes designed to release the cable at a controlled rate, maintaining tension without allowing it to go slack. Slack cable could kink or snap, while also preventing the tension from becoming too great, which could break it the same way. It was a system that required constant adjustment as the ship's speed varied, as the depth of the water changed, as the weight of cable already laid pulled differently on what remained aboard. The men who operated the machinery worked in shifts, never leaving it unattended. Thomas watched the cable arc off the stern of the ship and enter the sea. It disappeared beneath the surface immediately. There was something in this that he had not anticipated. He had understood intellectually that the cable would go into the water and sink to the seafloor, 2 miles down in the deep Atlantic. But standing there watching it actually happen, watching the thing they had built disappear into that immensity of water, irretrievably, continuously, mile by mile, was different from the intellectual understanding. The ocean was very large. The cable was very thin. He went below to check his instruments. The first week went well. They made good progress. The paying out machinery ran smoothly. The electrical tests that Thomas and his colleagues ran every few hours showed a clean signal. Current passing from the ship's end of the cable down through 1,200 feet of water to the seafloor, west through whatever lay between Valentia and the Great Eastern's current position, and registering cleanly at the other end. The cable was working. Thomas developed a rhythm. Test at 2, test at 6, test at 10, test at 2 again. Sleep in the intervals when the readings were good and the machinery was running cleanly. Eat when he could. Write in his log. He had not expected to find the ocean beautiful and found it beautiful. Not in the manner of paintings, which tended to dramatize the sea into something theatrical. The actual North Atlantic in summer was something else. A grey-green expanse that changed character with the light, that had a scale which made the Great Eastern, massive as she was, feel like a modest thing on an immodest surface. He stood on deck in the evenings when the watch was changing and looked at the water. He was thinking about the cable, about what it meant that a thread of copper and rubber was at this moment lying on the floor of this ocean, connecting 2 continents, carrying the nervous energy of civilization across 2 miles of water and 2,000 miles of distance. He was not a philosophical man by inclination, but the scale of what they were doing made philosophy difficult to avoid. He had also, in those first days, begun to understand the other men aboard. The electricians were a particular type. Careful, quiet, prone to long silences that had nothing to do with unfriendliness, and everything to do with the habit of sustained attention that their work required. His cabin mates were a Scotsman named Reed and a younger man from Manchester named Foyle, who had only been in cable work for 2 years, but who had a natural feel for the instruments that Thomas recognized and respected. The sailors were different. They had the offshore manner that Thomas had encountered on his only previous sea passage. A compact, self-contained way of moving and speaking that came from years of close quarters, and the knowledge that everything aboard depended on everyone doing their job without requiring explanation. They did not talk much to the electricians, but they watched the cable going over the stern with the same focused attention the electricians gave to their instruments. Everyone aboard understood what was at stake. On the 8th day out of Valentia, a fault appeared in the cable. A fault in cable telegraphy meant a break or compromise in the insulation. Electricity was leaking from the copper core into the surrounding sea instead of travelling along the wire to its destination. The signal weakened. Then it weakened further. Thomas read his instruments and felt the specific cold clarity of a problem that has been theoretical becoming concrete. He reported to the expedition's chief electrician. The chief electrician reported to the captain. The ship slowed. The cable was brought to the surface, a process that required hauling up several miles of it from the ocean floor, which was slow and technically demanding, and put enormous stress on the machinery. When the suspect section came aboard, Thomas examined it. A piece of iron wire from the outer armour had somehow worked its way through the insulation into the copper core. Not a large breach, not a dramatic failure, a small thing, A piece of wire, perhaps 2 inches long, driven by some motion of the ship or some tension in the cable into the gutta percha layer. 2 inches of iron wire in 2,000 miles of cable. They cut out the damaged section, spliced in new cable. The signal cleared. They resumed paying out. Thomas wrote the fault in his log. The date, the depth at which the fault was found, the nature of the damage, the repair. He noted that the signal had recovered cleanly after the splice. He did not write what he had been thinking while he examined that 2-inch piece of wire, which was 2,000 miles. And they had found this. What else was in there that they hadn't found yet? On the 11th day, the cable broke. Not a fault this time. Not a correctable insulation problem. The cable parted entirely, somewhere below the surface, at a depth where retrieval was at the edge of what the equipment could attempt. They tried. They spent 3 days attempting to grapple the broken end from the ocean floor, 2 miles down, with equipment that had not been designed for precisely this task. The grappling operation was unlike anything Thomas had seen. The grapple itself was a large iron hook arrangement, lowered on a separate rope. Miles of it, heavier rope than the cable, requiring its own winch to pay out and recover. You lowered the grapple until it reached the seafloor, then dragged it slowly along the bottom in the hope that it would catch the cable lying there. Then you hauled. Then you waited to see if what you had caught would hold as the weight came up through 2 miles of water. The waiting was the hardest part. You hauled, and the tension on the grapple rope increased as the weight below rose. And for long minutes there was no way to know whether the cable was coming up, or whether the grapple had snagged a ridge of rock, or whether the cable was there at all. The men on the winch worked steadily. The officers watched the tension gauges. Thomas stood at the stern with the others and looked at the rope going into the water and tried to read something from the sound of the winch. They came close twice. The grapple snagged the cable. The crew hauled. The tension built. And then the cable slipped. And then it was gone. Thomas stood at the stern and looked at the empty water. Around him, the men who had been working the grapple lines were quiet in the specific way of people who have been working very hard toward a thing that has just not happened. The captain made the decision to return to England. There was nothing else to do. They had laid 1,200 miles of cable. It was lying on the floor of the Atlantic Ocean, broken, at a depth that would have been accessible to nothing built by human hands. They sailed east. Thomas wrote in his log. He did not sleep well for the passage home. Thomas stood at the stern after the grapple slipped for the last time and felt something he had difficulty naming then and still had difficulty naming when he wrote about it afterward. It was not grief, exactly. It was not despair. It was the specific feeling of having worked at maximum effort toward a thing and having the thing remain undone. Not through lack of effort or skill or will, through the simple fact that the ocean was deeper than the equipment could reach, and the cable was heavier than the grapple could hold. and the mathematics of the situation had not come out in their favor. He stood for a while. Then he went below and wrote in his log, "In London, the failure was received in the way that public failures are received. There was analysis. There was blame. There was a significant body of opinion, and it was not an unreasonable opinion that the project was fundamentally flawed, that the ocean was simply too hostile an environment for a cable to survive, that the distances involved were too great, the depths too crushing, the unknowns too numerous for any cable laid through the North Atlantic to remain intact and functional. The committee of inquiry that examined the 1865 failure identified the likely causes and made recommendations for the 1866 attempt. The paying out machinery was redesigned. The testing protocols were revised. The procedures for handling the cable were tightened. Thomas attended the committee hearings, gave his testimony, described the fault, the break, the grapple attempts. He was asked whether he believed the project was viable. He said yes. He was asked why. He thought about this for a moment. He said, "Because we know more now than we did. Every failure teaches something. We know what went wrong, and we know how to prevent it. The ocean didn't change. Our understanding of it did." The committee chairman wrote this down. Thomas took the train back to London. He spent the winter revising his notes, reading everything that had been published about undersea cable laying, thinking about insulation, thinking about signal strength, thinking about the specific section of cable where the fault had developed and whether there was something in the way it was stored or paid out that had contributed to the failure. He wrote a report. He submitted it to the expedition's principals. He was invited to join the 1866 attempt. He said yes before they finished the sentence. He also spent a considerable amount of time that winter thinking about the men who had funded the project and were preparing to fund it again. This required a particular kind of mind that Thomas did not have and did not envy. His own work was measurable. A signal either arrived or it did not. A fault either existed or it did not. The mathematics of copper resistance and gutta percha insulation were not comfortable, but they were knowable. The mathematics of financing a project that had already failed twice, that required persuading investors to put capital into something with a demonstrated record of loss, operated by different laws entirely. And yet the money was found. The ships were provisioned. The cable was manufactured. He thought about this sometimes, without arriving at a satisfying conclusion. The world was moved, apparently, by both kinds of people, the ones who understood the instruments and the ones who could look at instruments that had consistently given bad readings and believe they would eventually give good ones. He was the first kind. He was grateful. Someone else was the second. The Great Eastern left Valentia Harbour on the 13th of July, 1866. She carried a new cable, heavier with improved insulation. Its manufacture supervised more carefully than the previous cable. She carried better paying out machinery. She carried the lessons of the previous year, built into every procedure and protocol the crew had been trained to follow. She also carried the broken end of the 1865 cable, recovered from the ocean floor in an operation that had taken 4 days of careful grappling work. The intention was to complete the 1865 cable as well as lay the new one if the new cable reached Newfoundland successfully. 2 cables, 2 connections between 2 continents. But first, 2,000 miles. Thomas took up his position at the electrical testing station within hours of leaving Valentia. The signal from the Irish shore end was clean and strong. He ran his tests, noted his readings, began the log that would run until Newfoundland. The ship moved west. The cable ran off the stern into the sea. The 1866 crossing was different from the 1865 crossing in ways that were difficult to articulate, but that Thomas felt clearly. The 1865 expedition had the energy of something new, the particular intensity of people attempting something that had never been done, where confidence and uncertainty were mixed in roughly equal measure. The 1866 expedition had a different quality. They had already failed. They knew what failure felt like. They knew the specific weight of standing at the stern of a ship in mid-Atlantic, looking at an ocean that had just taken back something they had worked to put into it. This knowledge made them more careful, not slower, more precise. The paying out team watched their machinery with an attention that went past professional competence into something more personal. The splicing crew ran their checks twice, where they had previously run them once. Thomas tested the cable more frequently than his schedule required, running extra readings in the early morning hours, when the watch was lightest and the ship was quietest. They were all, in their separate ways, waiting for the thing that had gone wrong last time. It did not come. On the first day, the signal held. On the second day, the signal held. On the 5th day, Thomas noted in his log that they were past the point where the fault had appeared in 1865. He wrote this without comment, in the same even tone he used for everything. But he looked at the notation for a moment before he moved on to the next entry. Past the fault point. Still going. The crossing had its difficult days. On the 4th day out of Valentia, the weather deteriorated. Not a storm, nothing that threatened the ship, but a sustained heavy swell from the northwest that made the Great Eastern move in a slow, rolling motion that the paying out team had to compensate for constantly. Swell affected the tension on the cable. When the ship rose on a wave, the tension increased. When it dropped into a trough, the tension slackened. Too much tension, or too much slack, and the cable could part. Thomas spent most of that day at his instruments, and most of the night there too. The signal held through the weather. He noted this with something that was not quite relief, because he had expected it to hold, but that was close enough to relief that he called it that in his log. On the 9th day, Reed found a small fault developing in a section of cable, still in the tank. Not serious, caught early enough to be cut out and spliced before it went over the stern. But it was a reminder. The cable was not inert. It was a living system of copper and rubber and iron, and every mile of it that disappeared into the ocean was a mile you could no longer inspect or correct. Thomas supervised the splice himself. He ran the test afterward until the signal was clean. Then he ran it again. There is a particular quality to the middle of an ocean crossing. The land is gone. It has been gone for days. There is nothing in any direction but water and sky. And the sky changes with the weather, and the water changes with the wind. But the fundamental fact of immensity does not change. You are a small thing on a large surface, and you are moving. And the moving is so slow relative to the scale of the thing you are crossing that progress feels theoretical, even when the log is recording it. Thomas found the middle passage useful for thinking. Not about the cable, specifically, about what the cable meant. He was not a man who had grown up expecting to do historic things. He was the son of a schoolteacher from Bristol. He had gone into telegraph work because it was interesting, and because there was work in it, and because the science of electrical transmission was one of those fields in the 1850s that were new enough that a careful man could still contribute something original to them. He had not imagined, when he started, that careful work in a basement testing room would lead to this. He was in the middle of the North Atlantic. Below him, 2 miles down, on a seafloor no human eye had ever seen, and no human hand would touch for perhaps centuries, a thread of copper and rubber was connecting everything he had left behind to everything he was heading toward. He ate his dinner and went back to his instruments. The signal was strong. On the 22nd of July, they raised the Newfoundland coast. The approach to Heart's Content Bay happened in the early morning, in a fog that made the land appear gradually, the low, dark hills emerging from the grey as the ship moved carefully through shoaling water. Men were at the bow, watching the depth. The paying out machinery was still running, the cable still going into the sea. Thomas was at his instruments. He ran a test at 4 in the morning. The signal came back from Valentia, clean and sharp. He ran it again. Clean and sharp. He wrote the reading in his log, added the time and the date. He sat for a moment in the dim electrical room, surrounded by his instruments, with the sound of the ship's machinery around him, and the sound of the sea, and the distant sound of men on deck, calling depth readings to the bridge. Then he went on deck to watch them bring the shore end in. Heart's Content Bay was a small place, a cluster of houses on a rocky Newfoundland shore. Fishing boats pulled up on the beach, a dock modest enough that the Great Eastern had to anchor offshore and send a tender in with the cable end. A small crowd had gathered on the shore in the early morning fog. Word travelled quickly in small places, and the arrival of the Great Eastern was not something you could miss even in poor visibility. She was too large for the fog to fully conceal, her dark hull emerging from the grey like a floating city. Thomas was at the stern when the cable end was prepared for landing. The shore end, a heavier, more armoured section of cable designed for the shallower, rougher coastal waters, where anchor chains and fishing gear and tidal action posed risks that the deep ocean did not, was attached to the main cable and lowered into the tender. A small party of men rowed it toward the beach. Thomas watched through a glass. The men who met them on the shore grabbed the cable end with bare hands. He put the glass down. He thought about Valentia Harbour, where he had watched other men receive a cable end the year before, on the other side of this ocean, with the same bare hands, with the same matter-of-fact purposefulness. There was something in this symmetry. The cable end received by working hands on a rocky beach in Ireland, and received again by working hands on a rocky beach in Newfoundland, that he found more moving than he expected. A small crowd had gathered on the shore. Word travelled quickly in small places, and the arrival of the Great Eastern was not something you could miss. The cable end was brought ashore in the tender. The men who received it on the beach were working fishermen who understood the sea and understood rope and wire and understood something about connecting things that needed connecting, even if the specific thing they were receiving at this moment was different in nature from anything they had handled before. Thomas watched from the deck of the ship. He thought about Valentia Harbour on the other side, where this same cable began, where men in a stone building were waiting for the signal that would tell them the connection was made, where the wire disappeared into the sea and ran east across the floor of the Atlantic, over the mid-Atlantic ridge, and across the abyssal plain, and up the continental shelf, and out of the water, at last onto an Irish beach. He went back to his instruments. He ran the test one more time. The signal came back from Ireland, 2,000 miles away. In the time it took him to look at the gauge, the messages that went out over the new cable in the days after landing were mainly official. Congratulations from governments, dispatch from the newspapers, commercial traffic beginning to move carefully as the operators on both ends learned the particular character of the new line, its signal strength, its timing, the way a Morse character sent at Valentia arrived at Heart's content, slightly softened by the resistance of 2,000 miles of copper wire, requiring a practiced ear to read cleanly. Thomas stayed in Newfoundland for 10 days, monitoring the cable, running tests, logging the signal quality at regular intervals. On the third day, they went back out to recover the 1865 cable. It took 4 days of grappling at depth to find the broken end and bring it to the surface. When it came up, it was encrusted with the life of the deep ocean, small creatures that had attached themselves to the iron armour during the year it had lain on the seafloor, 2 miles down, in water just above freezing, under pressure that would crush any living thing built for the surface world. They spliced in a new section, restored the insulation, tested the signal. It came back clean. 2 cables now. Ireland to Newfoundland, and Ireland to Newfoundland again. The Atlantic was crossed. Thomas Alderton returned to England in September of 1866. He had been at sea for the better part of 3 months across the 2 voyages. He had crossed the Atlantic twice. He had watched a cable go into the ocean and not come back. He had watched another one go in and hold. He was 32 years old, and he felt older than that, in a way he thought was probably permanent. Not unpleasant, not the exhaustion of overwork, but the settled weight of having been somewhere and done something that did not easily translate into ordinary life. The crossing back from Newfoundland had been calm. He spent much of it in his cabin, writing up the 1866 log in final form, transferring his field notes into the clear, careful hand he used for documents meant to be kept. He described each test, each reading, each small incident of the voyage. He described the fault Reed had caught in the 9th-day splice. He described the weather on the 4th day. He described the arrival at Hart's content and the instrument's reading at the moment the shore end was confirmed connected. He described none of what it had felt like. That was not what logs were for. He took a room in London for the winter and went back to work. The telegraph company that employed him had expanded its operations significantly in the years of the Atlantic Cable Project, and there was more work than he could easily manage. He supervised cable tests. He trained younger electricians in the methods he had developed. He wrote up his logs from the 1865 and 1866 voyages in a form that could be used by the next generation of cable engineers. He was not celebrated in the way that the expedition's financiers and promoters were celebrated. Those men received their recognition in the newspapers and at official dinners and in the civic ceremonies that marked the cable's completion. Thomas's name appeared in the technical reports and in the records of the electrical test, and in the log that he had kept faithfully from Valentia to Newfoundland and back. This seemed right to him. The cable was not a monument to any individual. It was the product of the accumulated work of thousands of people, most of whom would never be remembered. The men who had mined the copper in the ground, the men who had drawn it into wire, the women who had processed the gutta percha in the factories outside London, the sailors aboard every supply vessel, every escort ship, the engineers who had designed the paying out machinery and the splicing tools, and the grapples that had hauled a broken cable up from 2 miles of ocean. Thomas was one thread in a very long cable. He understood this without bitterness. It seemed, if anything, like the appropriate way for important things to get done. The Atlantic Cable changed things in the way that genuine infrastructure changes things. Slowly, then completely. In the first weeks, it was a novelty. Newspapers ran the transmitted messages as curiosities. Governments exchanged ceremonial greetings. The rates charged for sending a word across the Atlantic were high enough that only the most urgent commercial and official traffic justified the expense. A single word cost roughly $1 in 1866 money, which was a sum that working people did not casually spend. The first messages that crossed the cable were dispatches from heads of government and urgent financial traffic from the banks and commodity houses that could afford the rate and had business that justified it. Short sentences, compressed language, every word chosen for necessity. But the cable was there. And the fact of its existence, the fact that a message sent in London could arrive in New York in minutes rather than weeks, was not a fact the world could unknow once it had known it. The pressure to expand capacity and reduce rates was immediate and relentless. More cables followed. Better cables. Cables with more copper, better insulation, stronger armor. Cables that could carry more signals simultaneously. Then the rates came down, and the traffic increased. And the world in which 2 weeks was the fastest a piece of information could cross the ocean became the world in the history books. The world that people born after 1866 would know only as a story. That there had been a time when Europe and America were separated by weeks, when a market crash in London took a fortnight to reach New York, when the news of a war ended before it arrived. The cable compressed all of that. Not instantly, not all at once, but steadily, continuously, in the same way that the cable itself had been paid out, mile by mile, day by day, one coil at a time, coming off the drum in the tank of the Great Eastern and disappearing into the sea. Thomas lived until 1901. He was 67 years old. He had spent the intervening decades working on cables, the Mediterranean cables, the India cables, the lines that gradually connected the British Empire into a single telegraphic network spanning the globe. He was present at a number of cable layings that he did not consider particularly important and that posterity has largely forgotten. He considered the Atlantic cable the important one, not because it was first, though it was, but because of what he had felt, standing at the stern of the Great Eastern in the summer of 1866, watching that thin thread of copper and gutta percha disappear into the North Atlantic. He had been watching something impossible become possible, not through a single dramatic act, not through genius or luck, or the kind of moment that made for good stories, through persistence, through the patient accumulation of small correct things, day after day, test after test, mile after mile. He wrote this in a letter to a nephew who had asked him, near the end of his life, what he considered his most important work. He described the cable testing room in 1865, the fault, the 3 days of grappling in the open ocean, the return to England. He described the 1866 crossing, the clean signal at every test point, the morning they raised Newfoundland. He described Reed, the Scotsman who had caught the fault in the 9th day splice, who had gone on to work on the India cables and whom Thomas had seen perhaps 4 times in the decades since. He described young Foyle from Manchester, who had left cable work after the 1866 expedition and gone into banking, and who had sent Thomas a note when he read about the cable's completion in the newspaper, and whom Thomas had not seen since. He described the particular quality of standing at the stern of the Great Eastern in the North Atlantic in 1866, watching the cable go into the water on a clear morning when the sea was calm and the signal was strong, and there was nothing to do but watch and trust the work that had already been done. He wrote, "The ocean did not get smaller. It is still 2,000 miles across and 2 miles deep, and it does not care what we put into it, but we put something into it anyway, and it held. He sealed the letter. He sent it. It arrived the next day. Somewhere at the bottom of the North Atlantic, in the dark and the cold and the pressure, there is still cable. Not the same cable that Thomas Alderton tended in 1866. It was replaced many times over as technology improved and demand grew. But cable, continuous, patient, resting on the seafloor in the same dark it has always rested in, carrying signals at speeds that would have made Thomas's instruments useless and his testing methods quaint. It is doing the same thing the 1866 cable did, connecting 2 places that the ocean had separated, carrying information at the speed of light instead of the speed of a ship. The ocean is still there. The cable is still there. The line still holds. 2 miles of dark water above you, 2,000 miles of ocean between, and someone coiled a thread of copper into the deep, and it held. Whatever you are carrying tonight, set it down. The line holds. Rest.